Hello and welcome to my last OpenGL 1.1 tutorial, and after this point I will only use modern OpenGL functionality, but in this tutorial I will stick with the old immediate mode. So in this tutorial I plan to make a height map, which is basically generating terrains from an image. So how does it work? First of all, we get a BMP image, as we usually. I will load this BMP image. This is actually a grayscale image. A grayscale pretty much means that the RG and the B components of the image are actually equal. That's a grayscale image. And this image has obviously colors from black to white. The black represents the lowest possible height on the height map, on the terrain, for example, while the white represents the highest possible value on the terrain. So first of all, before I go into coding, let's create one of these. So I open up GIMP, and actually it's now English interface, so I can say what menus do I open. So it's a 100 by 100 menu image I created with file new. Okay, and actually here I use a cloud, which is basically just a noise. So I go to filters, render, clouds, and difference cloud. Okay, and here you can see a little preview of the image you will get. Okay, and of course you can manipulate these parameters as you want. Okay, and what else? You can use this new seed to generate a new kind of terrain. So as you can see, it's a white, so it's a grayscale image. And let's just generate one. Okay, let me zoom in a little bit. Just my mouse don't want to cooperate today. Okay, so as you can see here, there is a low point in the terrain, and here there are some mountains where it's white. Of course you can generate much better terrains, and of course you can draw it yourself if you want to. You can draw something like that, which is a big mountain or something, but for now I will use this. So let me save this into the folder. Okay, I have a folder created for this called height in my desktop, and actually I will save it as height map. As you can see, I've already did a little bit of testing and saved it, but I will save it again. So replace and use 32-bit option. That's an important one, since whenever we load we use a 32 whenever we access the pixels I use 32-bit integer. So I will use this format, which is basically 8-bit of padding and the rest of RGB components. So save, and actually I can exit from here now. Okay, and let's start to make the functions. I will create two functions actually. The first will only load the image and determine the height, and the second will actually draw. So it will be easier later on to convert it to a display list, a vertex buffer object, or something to enhance the speed a little bit. So this first function will be void, and I call it load height map. Okay, and this waits for obviously the name of the image, so const char and name, which is obviously a string constant. And the second is let's not make a second parameter for now, and let's make it a global namespace. So of course that's not a good practice to make it global namespace, but it's just a demonstration. So this second parameter will be a vector. Oh, by the way, I haven't shown you the program. I basically just get the camera and the functions header file and C++ file into the same folder, and actually some other, because it depends now a bunch of other files, so I get like 10 files into the same folder. So it's just basically a height map, and I implemented the camera. Of course I can move, but there is no reference point, since this is just a height map, so the moving cannot be seen, and that's it. So it's a very simple program. I simplified it. I don't think there is anything new in here. I turned on the death testing, initialize the skybox. Here I just draw the skybox, call the camera function, clear the screen and the buffer. Okay, and yeah, pretty much that's it. Nothing new in here. Whenever I click the screen I use the mouse in member function, which we have wrote for the FPS game. Okay, so load skybox, that's what I did. Okay, so let's load it to a surface. So SDL surface, and I call it IMG. What else should I call it? And SDL load BMP. So it will load the BMP called name. We should check if it is actually loaded, because we don't want, so IMG, we don't want to segmentation failure. So if the IMG is actually null, so it's not IMG basically, then let's just write out that the image is not loaded. Image is not loaded. Right. So it's probably because of the wrong file name. Okay, and actually return after this from this function. Now the image is loaded, so we have to go through all of the pixels. Oh, I haven't finished this did I? So the height map will be actually a matrix, but because I don't know exactly the size of matrix at this point, just after I load the image, I will actually not create a matrix, but create a vector in a vector, which is basically a matrix, just a dynamically allocated matrix. So std vector, and this will float, so it has a parameter float. So we have a vector which contains another vector which contains floats. Okay, and I call it height. We already did such a thing, so in vector, like in the side-scroller game. It's very simple, the basic idea that we have an outer vector which represents each column, and we have an inner vector which represents each row. And we can access the same way as we would access in any other matrices, so ij, so ij to access to the ith row, j column, right? So that's what it does. So it's basically just a matrix to store the height values. Now go through all of the pixels. So I will make a for loop for int I equals 0, I less than the img height, I plus plus. So the I variable will go in top to bottom, so in each row. And then I will make another for loop in here. So for int j equals 0, j I said less than img with j plus plus. That is go through each row. So we have the row which is pointed by the I index variable, and go through all of the pixels in that row. Okay, so if these were pixels, I go like this, and then this, so on and so forth. Although these are not pixels, I will show you in a moment what these are. Okay, so here I actually need to create a temporary vector which contains floats. So let's make one. So std vector and float tmp, because you need to push back a vector of floats into this outer vector. You cannot just use ij and put a float in there. You have to first create a vector and fill up this vector and push that vector back into this height, And now actually I have to create, I actually have to clear this tmp right here, so tmp.clear. Although the first time it's an empty vector, but the second time in the second row it already contains the first row. So we have to clear it, so it will only contain one row in a loop. Okay, that's right. And so the next thing is to actually get the current pixel, which is first of all get a uint. So convert to a uint32 this void pointer, which is pointed by the img pixels. So what this does is actually, because this is a 32-bit image, because we saved it earlier with GIMP as a 32-bit image, I convert every pixel to a 32-bit component, because we cannot really calculate with voids, right? So the next thing is actually use parentheses because of the precedence order, get the ith row, so I times img pitch divided by 4. This 4 is basically represented 4 byte, so 1 pixel is 4 byte, and add I to it. So we already did that, so I will not explain it right now. And actually this will be our pixel. So make a uint32 variable, and I call it pixel equal to this long line, which is basically that as get the ith row, j column right there. Okay, so we have the current pixel value. Now we actually have to separate it to different components, because this is a uint32 value, this is some number, but we want to know the r, g, and b components. So uint8 and r, g, b. I create three variable with uint8. This uint8 is pretty much unsigned char, so unsigned char, because it's 8-bit and it's unsigned, so it must be an unsigned char, so probably a type def. Okay, the next thing is actually to use a function which we haven't used earlier. This is the sdl get rgb. This get rgb function gets the rgb values from a uint32 value. So it's basically the pair of the map rgb, which converts to a uint32 variable from rgb components. This is basically the reverse get the rgb components. So it's pretty simple. First parameter of this is the actual pixel value, which we have get here. It's a uint32. Next is the format of the image, which we can get with img format. And the last is the pointer to r, pointer to g, and pointer to b. So now the r, g, and b contains the components. Now they are contains actually the same components, since as I said, in a grayscale image both the r, g, and the b must be equal. Okay, so now actually we have to calculate the height. So I use the tmp, which is our vector, and push back. I will push back a float I actually cast it to a float, and this is the one of these components. Since they are containing the same values, it doesn't matter which. I will use the R component. You can use the G and the B, of course. And I divide it by 255, which is basically make it that the values will be between 0 and 1, because 255 is the maximum for the R, so in that case it will be 1, and 0 is the minimum for the R, and in this case obviously it will be 0. So I basically just convert it from a value between 0 and 255 to 0 and 1. It's easier to calculate with it later on, plus we can use it as colors in OpenGL, since OpenGL use floating point number to represent colors. Okay, that was all in here. So in here, after the for loop, I just use the height.push back the TMP. So all I did was get all the pixels and use the height, this matrix right here, to store the number between 0 and 1 depending on the color. By the way, you can use you could store 3 different height maps in a same image. Of course, you will first get the R component, then a G component, and then the B components. Okay, so this function filled up the height. Now we need to actually render this height map. So void render height map. By the way, this part is obviously because it haven't used any OpenGL. It could be used with any render mode. So vertex, buffer object, or display list, anything. The render height map which will be needed to change in order to get different modes, so in order to make modern OpenGL. Okay, so this render height map is actually, we'll go through all of these height values. So for int I equals 0, I less than height.size, I++, actually height.size -1, I will explain it in a moment. Just I know that if I don't put this -1 here, I will forget and we will get a segmentation failure. And the next is int j equals 0, j less than height 0.size, I++. Actually I could have used height I.size, and actually this is j, isn't it? Yeah, so height I.size, but because all of the heights has the same width, so all of the rows in an image have the same number of columns, it doesn't really matter which index do I put here. Okay, so then in here I actually do the drawing. So GL begin, and actually I will draw like GL triangle strip. Let me open up GIMP and I will show you what that is. So here is how our terrain will look like. It will contain small squares actually. Okay, so small squares. So I will draw it like I draw this. I will add this point and then add this point right here, and then this point, which is define a triangle like this. And with triangle strip, I add another triangle right here. So now I have 2 triangles, and the triangle strip work like you first define 3 points, like this, and it will create a triangle. Then if you define one more point, it will use the other 2 points from the last triangle to make another triangle like this. And again, if you define one more point, it will create a triangle like this and this. Although I will not make it in a full row, although I could, so in that case I will have to create the next one here, and it would create this triangle right here, and then this here, and here, so it would actually be much more efficient. But I think it's just easier to see in this way if I just draw it by quad. But I cannot use GL quads because all of the points not lie on the same plane, and for OpenGL it has to lie on the same plane. So instead of drawing one quad, I use 2 triangles. Obviously this can have different heights, all of these sides, it would still work perfectly. So that's this triangle strip right here. Okay, and then actually I have to use vertex, I have to define the vertices, so GL vertex 3f. Okay, and actually let me create a constant to define the size of this, or which will probably get it as a parameter, so float size. Okay, this size will be how long each of the sides, if I find it, so how long this side is basically, and how long this size is. So this is what the size variable stands for. So I get the I times size, this will be the x coordinate, and then the y coordinate will be the height, which we have just filled up, ij, so get the current location basically, and then it contains a value between 0 and 1. So I will multiply it by some values. I could probably get another value right here, height. Okay, multiply it by height. So that will result then that here are the quads from the side. Okay, and for every single height I modify the wall value depending on what was the pixel color. If it was white, then I put it right there, so I move it up there. If it was black, then I leave it right here. So basically I just defining the height with this y value, and the z value is j times size. Okay, this was the first vertex, because I go vertexes like I define this vertex, then we can define this vertex right here, and then this vertex to create the first triangle. So now only I have to use the I plus size to define the next, because obviously it starts from 0, 0, then the next vertex will be 0, 1, and then 1, 0 for this vertex, and that will create a triangle. So let me create that. I will use copy and paste to save a little bit of time. So paste, paste, paste. Okay, so in here I use I plus 1, and actually not just there, but in the height as well, because we need to get the current height. So I plus 1 right here. There are no more i's in it, so I variable, so I don't have to modify anything else. Okay, and in here I use similarly just deal with the j, and in here as well, so j plus 1. Actually, I think I screwed up when I said that this is the first which I defined, this is the first which I defined, then this, and this will create a triangle, and then now this point comes, which is I plus 1 and j plus 1 as well, so it will be the last point. Okay, so I plus 1, obviously I use parentheses because we want to do first the addition and then the multiplication. I plus 1 and j plus 1 and j plus 1 right here, and use parentheses. So I defined basically the shape, and now I actually want to render the colors as well, so it will be easier to see the heights, because everything is the same color white, then it's hard to see. So GL color free F, and I basically just render with the current color. So I use the heights I and J for both the three components. If both three components equal, then this is actually grayscale image. Okay, so I just rendered some colors so it will be easier to see. And pretty much I think we are ready. So it's time for a demonstration. In the init function I will call this load heightmap function. So in here load heightmap, and if you remember I saved my heightmap as heightmap.bmp. Okay, and in the display function, after the camera is updated, I just call the render heightmap. Okay, and it has two parameters. One is the size, I'm not sure about that, let's be 0.1, and next the height, which is, I don't know, 10. We will see if it is okay or not. Right, and pretty much I think we are ready to compile and search for errors. Okay, I had one error, SDSR cannot be OpenGL CPP 26. I will look at there 26. Okay, let me see. Oh, I forget to put the parentheses after the pitch right there, because no, I put the parentheses there because pitch is not a function, it's a member variable. Now try it. Okay, I think it's compiled, so let's try to run this, and if I move right here, here is our heightmap, as you can see, although here is some problem. That shouldn't happen, and as you can see, probably the height is a little bit too big. Something wrong. That shouldn't happen. Let me go back, and of course this -1 right here, I forget the -1. I said that I will write a -1, but I forget it. So this -1 basically needed, so we will not go outside of the range, because I use the I plus 1 whenever I access this heights array, and because this I plus 1 and J plus 1, I can't go to the end of the array, since because of the +1 I go one outside of the array. That's why this -1 is here for. Okay, so now if I run this, oh, I forget to compile, didn't I? Don't worry, I compile it, and now, yeah, that's correct. Okay, and as you can see, here is our heightmap. Of course, you can put textures on it, so it will look more like realistic. And now if I experiment with these values right here, so I make it smaller, like 4, then the mountains will be smaller. Basically, the difference between the deepest and highest region will be smaller, as you can see. Okay, and actually I can decrease this value as well, so 0.01, which is 1/10 of the original, so it will be more smooth, but it will be smaller as well. And where it is, here, as you can see, this is very small, so now I have to use values like 0.4 to make the height. Okay, and actually before I go, let me show you oops, forget to put it in the screen. This often happens with me. As you can see, it's very small, but now it's very smooth okay, so let me create a bigger image, like 500 by 500 for this example. So new image, and 500 by 500 by 500, and use the filters, render, clouds, difference cloud, and let me go up with these values, and here it is. You can see, you can try luck with this new seed. Okay, and if I render it and actually make a big mountain, so I use this blend tool right here in my toolbox, so this blend tool, and make a mountain right somewhere. I will choose the gradient to foreground to transparent and make a big mountain here. I changed as well, the white color will be the foreground. So I made a big mountain right here. Oops, that was not what I intended, because I forget to change this linear to radial. Right, the radial basically creates a circle like that, so even bigger. Okay, that will be a fairly large mountain. So now if I save this image, so I will use the oops, wrong menu, so save as, and I will save this to a height map and replace. I use the 32-bit option as well. Okay, I saved it. Probably it will be a little laggy because immediate mode is slow, but the image is big. Okay, and do I need anything else? So let's run it. Okay, here it is. As you can see, it's quite big, and here is the mountain which I have drawn. Probably can use collision detection for this with the sphere. So with the sphere plane collision detection, although that will be a pretty ineffective way to test everything, so you should somehow divide this entire terrain to smaller subsections by using, I don't know, quad 3 or oct 3. I haven't covered these topics yet, but so this is the height map, and I think this should conclude the tutorial. Actually, I want to use this height map function to test each render mode, so the immediate mode and the display list and the vertex buffer object in the next tutorial, to determine which is the better. And of course the vertex buffer object will be in that tutorial as well. So thank you for watching, and have a